All right, let's do a few more probability questions. Where we left off the last time, let's see, questions 25 and 26. Let's look at 26 first, and we'll cycle back to 25. So it says there's a 30% chance of rain on Tuesday, 40% chance of rain on Wednesday. What is the probability that there would be no rain on both Tuesday and Wednesday? Okay, so again, we've got the code word there, and that means we have to multiply those probabilities together. So I really want to figure out is what is the probability of no rain on Tuesday and what's the probability of no rain on Wednesday? Let's start with Tuesday. Well, if there's a 30% chance of rain on Tuesday, it would stand to reason that there would have to be a 70% chance of no rain on Tuesday. So I'm going to put that as 0.7. Okay? And then if it's 40% chance of rain on Wednesday, then presumably there would have to be a 60% chance of no rain. So we can put that as 0.6, and there it is. We just multiply those two things together, it gets us to 0.42. So it would be a 42% chance that both of these days there would be no rain. Okay, that's it. Done. Now, for 25, this one's a little bit weirder because we've got this phrase here where it says we want to know how, if we toss 3 times, we want heads to appear exactly 2 times. What makes this a little bit complicated is that we don't know exactly what the order of heads would be. We just need 2 of them. So okay, this is now getting into what's called combinations problems, and choose, whatever. I don't want to get into that right now in this video, so we're going to keep it relatively straightforward. But let's just think about this. Remember, the basic probability is that we need to have events that we want, so I'll put want divided by total number of events. Okay, well, if I'm flipping a coin 3 times, how many different events or outcomes could there be? If you think about it, each time we toss it, there's 2 things that could happen. Right? I could get either heads or tails. So 2 things the first time, 2 things the second time, 2 things the third time. There would be a total of 8 different possible outcomes. Okay? If that confused you, pause the video, reflect on that. Okay? So we know that out of the total, flipping the coin 3 times, there's 8 different things that could happen. Now, out of those 8 things, how many of them have heads in there exactly twice? Well, just to make this short, since it's not too terribly difficult to do this kind of by brute force, we can think about how many different ways could we get 2 heads? Well, way number 1 could be something like heads first, heads again, and then tails. Another possibility would be we could do heads first and then tails and then heads. Or we could do tails and then heads and then heads. Hopefully that kind of makes sense. There's only 3 different ways that we could end up getting exactly 2 heads. So we would say that the odds out of those 8, how many of them would have exactly 2 heads would be 3/8. Okay. There is another way to do this, which would be, and I'm not going to terrify everybody and do it in this video, but another way we could calculate for this part of how many possible different ways could we get exactly 2 heads. It looks something like this. We could say we're flipping the coin 3 times, and out of those 3 times we want exactly 2 heads. Something called 3 choose 2, and that formula looks like this. It would be 3 factorial divided by 2 factorial times 3 minus 2 factorial. Okay, yeah, I'm sorry, I get a little excited over these. You don't have to worry about that. That's what's called a combination formula, and we will discuss that in another video. But if you worked all this out, you'd end up getting exactly 3. So what that would tell you is that there are 3 possible ways that we could get exactly 2 heads, given that we flipped the coin 3 times. Okay, but anyway, more on that later. So the odds of that happening, the answer to this would be 3 out of 8. Okay, now what I would like to do is I'd like to explore 3 more complicated problems involving probability. These are much harder than what you would expect to see on the GRE, but they're a good indication of all the types of ways that these probability rules could be applied. So if you're not interested in that, just pause the video. You've gotten enough so far to get you through whatever probability would be thrown at you on the GRE. But if you're curious, continue watching. All right, let's look at this one. So this one says, in a game, we have to do 3 tasks. We have to flip a quarter, success is heads, roll a die, success is 6, pick a card, and success is picking a spades. Okay, so we have 3 different things that we have to do, and each has its own probability of success. If any of these tasks are successful, then you win the game. What is the probability of winning? Okay, so let's just break this down for code here. Any of the tasks, meaning we've got an or problem, right? Either I flip a quarter, I have success there, or I could flip a die, roll a die, or I could pick a card. So if I'm trying to figure out what's the probability of winning, all I'd have to do is calculate what's the probability of winning for each of these 3 separate tasks, and then just add those probabilities together. So let's do the first task, flipping the coins. I'll put coin. The odds of winning that one would be we have to get a heads, right? Well, what's the probability of getting a heads if we flip a coin? It'd be 1 out of 2, right? Now, what about success for the die? For the die, the success here would be rolling a 6. Well, the odds of that happening is 1 out of 6, right? And then for picking a spades card, the odds of that happening, 1/4 of all of the cards in a deck of cards would be spades, right? So I'm going to say for the card, the odds of randomly selecting a spade would be 1/4. Okay? So then since any of these things, it says if any of them are successful, we win. So it could be this or that or that. We add all those probabilities up. So the probability of winning would be 1/2 plus 1/6 plus 1/4. We could do conversions there. I don't really care. You can calculate what that would be. Oh gosh, now I actually do kind of care. All right, fine. Let's do this. Let's see. That'd be 6/12 plus 2/12 plus 3/12 is going to be 8. It's 8. It's 11. No, 9/12 is equal to 9 out of 12 times you would expect to win. That can be simplified to what, 3/4. So 75% chance of winning this particular game. Okay? But the key there was we had to calculate each probability separately, and then we knew that we were supposed to add them up. Okay? That's really it. Again, to emphasize, with probability, we just need to calculate what is the probability of any particular event happening, if we've got more than one, and then decide whether we need to add the probabilities or multiply them. Simple as that. Okay. Now let's try complicating it a bit. Look at this one. Switch colors. The same game. Okay, so I'm not going to read over all that. It's all this stuff, but the change here now is it says, look, if you get tails, if you get heads, you win. If you get tails, then we move on to the second test. So now we're doing things sequentially. First this one, then that one, then the third one. Okay? And the second task is rolling. If you roll a 6, you win. If you roll anything other than a 6, then you have to move on to the third task. What is the probability of winning? Okay, this is a little bit different now. Because if you think about it, we kind of have these different paths. Let me just start you here. I'm going to illustrate it by drawing a diagram just to kind of show it, and then we won't have to do that for future to solve this. But actually, this video is getting a little long. I'm going to pause on this one as well. Sorry, everybody.